So today we are going to continue with chapter 9 of grade 11 maths, which is sequence and series. And today we are going to learn how to find sum to n terms of some special series. Okay, so let's start. So sum to n terms of some special series, and the first is sum of first n natural numbers sigma n equals to 1 plus 2 plus 3 up to n, where n is some natural numbers. This is given by n into n plus 1 upon 2. Second is sum of the squares of first n natural numbers, that is sigma n square, which is equal to 1 square plus 2 square plus 3 square and so on up to plus n square, which is given by n into n plus 1 into 2n plus 1 upon 6. And the third one is sum of cubes of first n natural numbers, which is sigma n cube equals to 1 cube plus 2 cube plus 3 cube up to plus n cube, and this is given by n into n plus 1 upon 2 whole square. Remember this symbol sigma n means sum of n natural numbers, sigma n square sum of squares of first n natural numbers, and sigma n cube, that is the square of sum of the square cubes of first n natural numbers. Clear? So pause and note down these three important formulas. So let's start exercise 9.4, and question 1 is find the sum of two n terms of the series 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5 and so on. So here an will be equal to nth term of the first AP, that is 1, 2, 3 and so on, and product multiplied by nth term of the AP 2, 3, 4 and so on. So Sn, sum of n terms will be equal to sigma n square plus sigma n, and we have the formula for sigma n square, which is equal to n into n plus 1 into 2n plus 1 upon 6, and sigma n equals to n into n plus 1 upon 2. So simplifying this, taking LCM and simplifying this, we will get our sum as n into n plus 1 and plus 2 upon 3. Clear? Pause and note down the solution. Moving to question 2. Find the sum of n terms of the following series 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 and so on. So the given series is 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5. So an will be equal to that nth term will be equal to nth term of first AP, that is 1, 2, 3 and so on, multiplied by nth term of the second, that is 2, 3, 4 and so on, multiplied by third AP, that is nth term of the 3, 4, 5 and so on. So we get n into n plus 1 into n plus 2. On simplifying, we get an equals to n cube plus 3n square plus 2n. So the sum will be equal to sigma n cube plus 3 into sigma n square plus 2 into sigma n, and we have the formula for sigma n cube, which is equal to n square into n plus 1 whole square upon 4 plus 3 into sigma n square equals to n into n plus 1 to n plus 1 upon 6 plus 2 into n plus 1 upon 2. So next we have, now taking n into n plus 1 common, we get n into n plus 1 multiplied by n plus 1 upon 4 plus 2n plus 1 upon 2 plus 1. So on simplifying, we get n plus 1 upon 4 into n plus 1 plus 2 into 2n plus 1 plus 4. So multiplying the bracket, we get n into n plus 1 upon 4 n square plus 5n plus 6 upon, and this finally will get n into n plus 1 n plus 2 n plus 3 upon 4. Clear? So pause and note down the solution. Next is question number 3rd. 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus and so on. So the nth term will be equal to an will be equal to nth term of the AP 3, 5, 7 and so on, multiplied by nth term of 1 square, 2 square, 3 square and so on. So we get an equals to 2n cube plus n square. So Sn will be equal to 2 into sigma n cube plus sigma n square. So putting the value of sigma n cube, which is equal to n plus 1 upon 2 whole square, plus sigma n square equals to n into n plus 1 to n plus 1 upon 6. So taking n plus 1 upon 2 common, we get n plus 1 upon 2 into n plus 1 plus 2 n plus 3. On simplification, we get it at n upon 6 plus n plus 1 into 3n square plus 5n plus 1. Clear? So pause and note down the solution. Moving to question 4. Find the sum of 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus and so on. So here n equals to 1 upon nth term of 1, 2, 3 and so on, multiplied by nth term of 2, 3, 4 and so on. So we get 1 upon n into n plus 1, which is equal to n plus 1 upon n into n plus 1 minus n upon n plus 1. So on simplification, we get the n equals to 1 upon n into 1 upon n minus 1 upon n plus 1. So putting n equals to 1, 2, 3 and so on, we get a1 equals to 1 minus 1 upon 2, a2 equals to 1 upon 2 minus 1 upon 3, a3 equals to 1 upon 3 minus 1 upon 4 and so on. We get an equals to 1 upon n minus 1 upon n plus 1. So adding the terms in LHS and cancel out diagonally, we get Sn equals to 1 minus 1 upon n plus 1, which is equal to n upon n plus 1, which is our required sum. Clear? So pause and note down the solution. Next we have question number 5. Find the sum to n terms of the series 5 square plus 6 square plus and so on 20 square. Now we can solve this like 1 square plus 2 square plus 3 square plus 4 square, and subtracting this from 1 square plus 2 square plus 3 square up to 20 square. We'll be left with 5 square plus 6 square plus 7 square plus 20 square. Clear? So we are getting sigma n equals to 1 to 20 n square minus sigma n equals to 1 to 4 n square. Now sigma n square will be equal to what? For first 20 will be 20 into 20 plus 1 into 2 into 20 plus 1 upon 6, and sigma square for n equals to 4 will be equal to 4 into 4 plus 1 into 2 into 4 plus 1 upon 6. We applied the formula sigma n square equals to n into n plus 1 2n plus 1 upon 6. So on simplification we get 2870 minus 30, which is equal to 2840. Clear? So pause and note down the solution. Next is question number 6. Find the sum to n terms of the series 3 into 8 plus 6 into 11 plus 9 into 14 and so on. So here an will be equal to what? Nth term of the first AP, that is 3, 6 and 9 up to and so on, and multiplied by nth term of the second AP, that is 8, 11, 14 and so on. So on simplification we get an equals to 3n into 3n plus 1, which is equal to 9n square plus 15n. So sigma Sn will be equal to what? 9 into sigma n square plus 15 into sigma n. So putting the formula for sigma n square, we get 9 into n plus 1 2n plus 1 upon 6, and using the formula for sigma n we get 15 into n plus 1 upon 2. So taking n into n plus 1 common, we get n into n plus 1 multiplied by 3 upon 2, 2n plus 1 plus 15 upon 2. So again taking 3 by 2 common, we get 3 upon 2n, n plus 1, 2n plus 1 plus 5. So on simplification this gives 3n into n plus 1 n plus 3. Clear? So pause and note down the solution. Moving to question 7. Find the sum to n terms of each of the series, which is 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square and so on. Now the given series is 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square and so on plus and up to n terms. So here n will be equal to what? Sigma n square, 1 square plus 2 square plus 3 square and a term. So n we are getting n into n plus 1 2n plus 1 upon 6, which is equal to 1 upon 6, and 2n square plus 3n plus 1. So we can write this an as 1 upon 6 2n cube plus 3n square plus 3n. So taking the sum, Sn equals to 1 upon 6 into 2 sigma n cube plus 3 into sigma n square plus sigma n. So using the formula for sigma n cube, sigma n square, sigma n, we get Sn equals to 1 upon 6 into 2n square into n plus 1 whole square upon 4 plus 3n n plus 1 to n plus 1 upon 6 plus n into n plus 1 upon 2. So taking n plus 1 common, we get n plus 1 upon 6 into n plus 1 upon 2 plus 2n plus 1 upon 2 plus 1 upon 2. So on simplifying, we will get the required sum as n into n plus 1 whole square into n plus 2 upon 12. So pause and note down the solution. So moving to question 8. Find the sum of the n terms of n into n plus 1 n plus 4. So we have an equals to n into n plus 1 n plus 4, which is equal to n cube plus 5n square plus 4n. So Sn will be equal to sigma n cube plus 5 into sigma n square plus 4 sigma n. So applying the formula for sigma n cube, sigma n square and sigma n, we get Sn equals to n square n plus 1 whole square upon 4 plus 5 into n plus 1 to n plus 1 upon 6 plus 4 into n plus 1 upon 2. So taking n into n plus 1 common. So we get n into n plus 1, n plus 1 upon 4 plus 5 into 2n plus 1 upon 6 plus 2n. So on simplifying, we will get the required sum as Sn equals to n into n plus 1 n plus 2 3n plus 17 upon 12. Clear? So pause and note down the solution. So moving to question 9, we have the an equals to n square plus 2 power n. So putting n equals to 1 2 3 up to n, we get a1 equals to 1 square plus 2 power 1, a2 equals to 2 square plus 2 square, a3 equals to 3 square plus 2 cube and so on, n equals to n square plus 2 power n. So adding, we get Sn equals to 1 square plus 2 square plus 3 square up to n square plus 2 power 1 plus 2 power 2 plus 2 power 3 up to 2 power n. So we get sigma n square plus sum of n terms of the GP. So sigma n square equals to n plus 1 into 2n plus 1 upon 6, and using the formula for GP, that is sum is equal to a into r power n minus 1 upon r power minus 1. We get 2 into 2 power n minus 1 upon 2 power minus 2 minus 1. So the required sum will be equal to n upon 6, n plus 1, 2n plus 1 plus 2 into 2 power n minus 1. Clear? So pause and note down the solution. Next we have question 10. Find the sum to n terms of the series 2n minus 1 whole square. Nth term is given. So an equals to 2n minus 1 whole square, which is equal to 4n square minus 4n plus 1. So Sn will be equal to 4 into sigma n square minus 4 into sigma n plus 1 into n. If we add 1 n times, we get n. So using the formula for sigma n square and sigma n, we get 4 into n plus 1 to n plus 1 upon 6 minus 4 into n plus 1 upon 2 plus n. So taking n common, we get n into 2 upon 3 n plus 1 to n plus 1 minus 2 into n plus 1 plus 1. So on simplifying, we are getting n upon 3 4n square minus 1, and factorizing, we will get our final answer as n upon 3 2n plus 1 into 2n minus 1. So pause and note down the solution. With this we end the exercise 9.4. So solve the exercise and also the sums given in the example. Clear? Thank you and all the best.